I'm Nurul Nordin from UMPSP Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to chapter number 4. This chapter, Basic Command Line Interface (CLI) and Terminal Usage. The command line is a powerful tool that allows you to interact with Raspberry Pi operating system efficiently. Whether you are managing files, installing software, or setting up permissions, mastering the command line is essential for working with Raspberry Pi. By the end of this lesson, you will gain essential skills to navigate and manage files in Linux environment for Raspberry Pi OS. First, you will learn how to navigate the Linux file systems using essential commands, allowing you to explore different directories and locate files efficiently. Next, you will be able to execute basic shell commands, including ls to list, for example, pwd to check the current directory, and cd to move between directories. These fundamentals commands are crucial for managing files and folders within the system. Next, you will also learn on how to install and manage software packages using the APT, the Package Management System in Raspberry Pi OS. This will enable you to install new applications, update softwares, and manage dependencies effortlessly. Lastly, you will gain an understanding of user permission and learn how to control access to files and directories. This is key security feature in Linux that ensures only authorized users can modify and execute specific files. With these skills, you will be equipped to operate Raspberry Pi efficiently using the command line interface. Let's start. The command line interface or CLI plays an important role in programming. But why is it so important? Firstly is efficiency. The command line allows for faster execution tasks compared to the graphical user interface. Secondly is remote access. Many Raspberry Pi setups operate without a monitor, making remote control essential. With CLI, you can connect your device using SSH, allowing full control from elsewhere. Third, automation. It enables you to automate tasks using script, whether it's running system updates, managing files, or schedule operations. Finally, low resource usage. Unlike graphical interfaces, the CLI consumes minimal system resources, making it ideal for lightweight embedded systems like the Raspberry Pi. By the end of this chapter, you will gain hands-on experience with Linux command, helping you to see the full potential of Raspberry Pi. The shell is a crucial component of the Linux operating system. It serves as an interpreter, processing user inputs and executing commands. Unlike graphical interfaces, the shell provides a text-based user interface, allowing users to interact directly with the operating system. In the Raspberry Pi OS, also known as Raspbian, the default shell is Bash. Bash stands for Born Again Shell and is one of the most widely used command line interfaces in Linux. Using the shell gives users more precise control over the system, whether managing files, configuring networks, or automating tasks. Another advantage is remote control. Many Raspberry Pi setups are accessed remotely, and the shell allows users to control their devices via SSH without needing a monitor or keyboard attached. However, efficiency in using the shell requires some memorization. Mastering basic commands can significantly improve productivity and system management. Throughout this chapter, you will learn how to navigate Linux shell and use it to perform essential tasks on your Raspberry Pi. The terminal is a text-based interface that allows users to enter commands and view their output. Essentially, the terminal is the environment where the shell runs. When you open a terminal, you are launching a window that provides access to the command line interface. On Raspberry Pi OS, also known as Raspbian, the default terminal application is LX Terminal. This lightweight terminal emulator provides a simple and efficient way to interact with the system. Through the terminal, users can execute commands, manage files, install software and control hardware, all without using a graphical interface. As we move forward, you will gain hands-on experience using terminal to navigate the Raspberry Pi system and perform essential tasks. The Linux system follows a structured hierarchical design. At the top of the hierarchy is the root directory, represented by a single /. From here, the system branches into multiple subdirectories, including important folders such as home, etc. and var, each serving a specific purpose. To navigate this file system efficiently, we use essential command line tools. The first command, pwd, for example, prints the current working directory, allowing users to see their exact location and their file structure. Next, we have ls, which lists files and directories within the current location, helping users explore their system. Finally, the cd command, which allows users to change directory, moving between folders at ease. Mastering these command lines is crucial for managing files. In Linux, text editor function much like word processors, but they are simpler and optimized for working within the command line. Some of the most commonly used text editors includes Emacs, Vi, and Vim, each offering unique features for editing and managing files. Apart from text editor, Linux provides quick way to view the file content. Commands like cat, head, and tail allow you to display files directly with the terminal. Cat prints the entire content. Head shows the first few lines, and tail displays the first few lines of the file. Next, let's have a look into how to manage packages with apt. Note that this is not apartment. apt stands for Advanced Package Tool. Now, apt is the package management system to install, update, and remove software. To update package list, use superuser-do sudo apt update. To install new package such as Python, type sudo apt install Python 3. And to upgrade, type in sudo apt upgrade. In Linux, a process is simply the execution of a program. Each program you run, whether it's a text editor, script, or a system service, create a process. Linux is a multitasking operating system, meaning multiple processes can run simultaneously. To view activity processes, you can use the ps command. This will list all the running process along with their process ID. If the process becomes unresponsive or need to be restopped, the kill command can be used to terminate it. By specifying the process ID, you can safely end any running task. One important rule when shutting down a Linux machine is to never just unplug. Instead, always use shutdown command to power it off properly. This ensures all processes terminate safely and prevents data corruption. Understanding how to manage a process is crucial for maintaining system stability and efficiency. In this slide, we'll explore file permission and how to interpret the output ls-l command. First, the ls-s lists files in a detailed format, displaying their permission, ownership, size, and modification time, such as the one shown here. Now let's break this down each column. The first column represents the permission, indicating who can read, write, or execute the file. The second column shows the number of hard link. A hard link is an additional reference to the same file on the file system. Unlike a shortcut, it directly links to the file's data. The file is only fully deleted when all the hard links are removed. The third and fourth column displays users or owner name and group name, both of which define who has access to the file. The fifth column indicates the file size in bytes, and the sixth and seventh column show the dates and the time of the last modification. The sixth and seventh column shows the date and time of the last modification. Finally, the last column is the file name itself. Understanding this structure helps us manage file access and security in Linux effectively. In Linux, file permissions determine who can access the file and what actions they can perform. The first character represents the file type. D means directory. Dash indicates a regular file. L represents a symbolic link. The next 9 characters define permissions for 3 categories of users. The owner, which is the user, the person who created or owns the file, group, other users who belong to the same group as the user, and others, everyone else on the system. Each set of these characters represents permissions. R means readable, W means writable, X means executable, and dash means no permissions is granted. This is an example of a file permissions in Linux. The first character dash indicates that this is a regular file. The next 9 characters define the permissions for 3 categories of user. The owner, Hazlina, has read and write permissions, meaning she can view and modify the file. The group Hazlina has read-only permissions, meaning they can view the file but cannot modify it, whereas the others also have read-only permissions, allowing them to view but not edit the file. These permissions ensure that only the file owner can make changes. These permissions ensure that only the file owner, Hazlina, can make changes, while others can only read the content. So here, what it means is that for the file notes.txt, the owner, Hazlina, can read or write, while the groups and others can only read the file.